and they've got a weather balloon and cameras. Tell us, what is this whole thing?
This is SpaceBridge. We're a project working out of the NoiseBridge collective. Essentially what we're doing is we're sending out some standard off-the-shelf equipment, and we're sending it up 70 to 100,000 feet into the air. The equipment that we're actually using is standard off-the-shelf equipment, like just candid cameras we picked up off of eBay for just a couple of dollars each. We're routing all this through. We're tracking all this via an application we're running on a G1. The G1 is actually going in and grabbing the GPS coordinates off of the internal system and then text messaging the ground crew where it is. We're also routing the GPS information through Google Maps so that we actually know where it is and we watch it and map it real time. We have a redundant system on board because, well, we don't want to lose it, which is a standard GPS unit that we're passing through a open tracker board into a radio. We have all of this packaged up into a styrofoam payload. The payload is housing the cameras, the radio, the G1, and doing some thermal insulation to ensure that everything's staying nice and cozy and warm and doesn't give out due to the harsh environment we're dealing with. We're taking all of this and launching it up in space using a standard military-grade surplus weather meteorological balloon. Just standard latex.
Are these balloons really expensive?
No, they're about $25 off of eBay. They're actually surplus. Military government's just giving them away essentially.
So why is there so many on eBay? Was this part of a large purchase they did or self-flight?
So meteorological balloons were previously being used by the military for a variety of purposes, one of which was artillery. In order to do an artillery shell, they'd have to find out where the wind's blowing. So they use these meteorological balloons to track the air currents of the different layers. And that way they know when they're actually using their long-range artillery, where they actually have to be aiming and what type of adjustment they have to make. They're doing other various things for like flight and air traffic control as well. So there's a variety of purposes that the military is using. Unfortunately, there's a shelf life for these balloons. And what we're picking up is these meteorological balloons that have passed their shelf life. They're still good, but as they have passed their shelf life, the government passes them on, picks up new, more reliable balloons.
Okay.
So we were able to pick them up dirt cheap and build them up and use them for our project.
So tell us, there's this camera that's up on your balloon,
yes,
up above us, and then I have this screen right here. Would this be something you're looking to launch? Have you launched this almost real-time video?
We are not getting real-time video off of our launches. One of the problems we're having is the distance that we're dealing with, since we are flying so high and it travels so far, that getting a point-to-point communication with them is very, very difficult. What you're seeing on the screen right now is actually only possible because we're at such a small range with the balloon flying directly above us. What we have to do with our actual launches is do a full payload recovery. We're working on doing a peer-to-peer transmission via radio waves, but unfortunately the equipment is very expensive and heavy. It requires certain licensing that we have not been able to get around as of yet.
Okay.
So, because the payload recovery is so ingrained and important to our launch, that's why we actually are doing two different redundant systems for our tracking. Both our primary tracking, which is the G1, as well as our redundant tracking, which is the radio. And we are launching in a relatively safe place. Due to the regulations, we have to avoid a lot of airspace and stuff like that. So we're launching in the Central Valley, where we actually know pretty good where it's going to be traveling, and we know that it's going to be falling in a pretty harmless area where we have easy access to most of the area. We're hitting most of the farmland down the Central Valley.
Okay, so I take it as what? Is it 4 pounds or less? There's a regulatory, can you explain?
Correct. In order to launch and fit into the loophole or into the FCC regulations that we're doing, we actually have to have a 4-pound payload or less. We're getting kind of close to the 4-pound payload right now, but that's because we keep doing more and more equipment, more and more readings and instruments on board. The regulations are pretty much in there to ensure that airplanes and other flight craft will remain safe. Essentially, we cannot interfere or endanger any aircraft. So the 4-pound plus a fairly large area is required, as well as visibility. There's really a meteorological balloon, just standard surplus military grade. it's latex. And what happens is, when we launch the balloon, we're doing about a 6-foot diameter of the balloon. The balloon's only about 6 feet. But as it's rising up, because the outside atmosphere is dropping, we're getting down to about 2 to 1% atmospheric pressure. The balloon keeps trying to regulate and keep keeping the pressure, internal and external pressure, the same. So it keeps stretching the latex, stretching latex, where the latex gets down to about 30 feet. Once the latex gets 30 feet, it just can't hold it anymore. The internal, it just bursts. And with the rupturing of the balloon, our payload finally starts falling back to Earth. But we don't actually have enough oxygen up there. There's not enough atmosphere to do anything. This just kind of falls down for a couple thousand feet before finally our nice, brightly visible parachute gets enough atmosphere to catch and deploy and start to actually control and slow its descent. Where it finally lands in someone's backyard and I get to be the little kid again and knock on some door and go, "Excuse me, sir, but I seem to have got my toy in your backyard. Can I get it?"
Well, okay, 100,000 feet. There's not much air molecules up there.
No, so it falls for a long time before we actually get atmosphere to pick up the balloon.
But we're talking about a pressure that's 99% less than here at sea level.
Yes.
And yet these things, but tell us about with you and everybody else, it must be really exciting to get your very own near space pictures and data.
I cannot express the joy and the excitement you get when you actually pull up the camera and you look at the pictures for the first time. We all actually sit there and go, "Oh my God, I took a picture and can clearly see the curvature of the Earth." There is no question that the Earth is round. I have proven it. There's no question that the sky is blue because of light diffusion. I have proven it. There's no question about how big the Earth is. I can take this picture I took, take points, and actually map it. All this information I have proven, and I get these gorgeous pictures of space as evidence.
Okay, so tell us, so your group, how do people find out more about it?
So you can visit us online. We're a particular project out of the NoiseBridge hackerspace. Unfortunately, as many cases with this, we're really eager about actually doing it, and stepping back and actually documenting it seems to always be an forethought. If you head out to our website, www.noisebridge.net.
NoiseBridge.
NoiseBridge. NoiseBridge. NoiseBridge.
.net.
NoiseBridge.net. That is the site for the base that we're actually doing all of this out of. But on there, we actually have a project page there. So if you do a search for SpaceBridge, our project, you can actually get our project page, the activity that's going on with the project, keep up to date on what's happening, and sign up for our message blog. So that as we're communicating what we're doing, you can actually follow along what's happening, what are the current things we're dealing with, and how we're overcoming them. You can also link to all of our images and video of what we've done and what we're going to be doing.
Okay, great. All right, well, thank you, Tim.
Thank you. And I hope to see you all online.